It's not rocket science.
Stars usually form black holes. Stars are held in balance by two opposing forces. The inward pressure of gravity of the star countered by the outward pressure from radiation exerted by the star. At the core, millions of tons of hydrogen are being compressed into helium. This fusion reaction is exothermic, so it releases more energy than it requires to go on. As the star reaches the end of its supply of hydrogen, it collapses a small amount, but then switches to its supply of helium, then its supply of carbon, and then its supply of hydrogen. Again, it collapses a small amount each time, and in effect being caught by the new stage of fusion. As it continues to do this, it counters its own compression. Stars the mass of our Sun usually stop there. They become a white dwarf and cool down. Stars with a mass of about 5 times our Sun continue up the periodic table. They continue on to silicon, to aluminium, to potassium, but then finally stop at iron. So most stars stop at the fusion of iron. This is because no energy is produced when iron is fused. So the outward pressure stops and gravity wins out. This means the star implodes. The mass of the star is then compressed into a smaller and smaller fraction of space because of gravity pushing it inwards further and further. This means the velocity needed to escape this area exceeds the speed of light. At this point, a black hole has been formed.
Other ways black holes are formed. Another way to form a black hole is when two neutron stars collide. There are also supermassive black holes at the heart of every galaxy, and the formation of these is still an open field of research. Schwarzschild radius. The Schwarzschild radius is the radius that the mass of an object must be compressed to for the gravity to be acting as strongly as the speed of light. This means that light cannot escape, hence the name black hole.
The theory of gravity. So, imagine the universe is flat, and anything with mass will bend the universe downwards, creating this bowl-like shape. Anything else will be attracted towards the centre of the bowl, therefore creating this theory of gravity. The making of a black hole. So, in the top left we can see the Sun, also creating this bowl-like shape because it has mass. The white dwarf below it bends the universe more, creating more gravity, and the neutron star below it creating even more. The black hole on the right also has this bowl-like shape, except for this time it creates like a cylinder because it has a critical amount of mass. With an event horizon, the event horizon is the point of no return.
Massive black hole. We are unable to observe the size of the black hole because we will not be able to see it physically. So we have to look at the companion stars that orbits the black hole to obtain the mass. We can tell whether the companion star is orbiting the star by whether we can see what's in the middle of what the star is orbiting. We can also tell by the large value that we obtain from calculating the mass by using Kepler's third law shown here.